going to be talking about ideal mechanical advantage, actual mechanical advantage, efficiency, and effort. So Ton will introduce our system.
So this is our machine. Basically, what a machine does is it uses like materials like wood, metal, string to make your job easier. Like say to lift this 8-pound weight, you would need like a directly if you were just to lift it like this, you would need like a directly proportional amount of work to do so. But with the machine, it makes it easier for you to do it by
using pulley
yes,
systems.
using pulleys and stuff. Like it's using material, it lessens the workload, the physical workload that you need to do. So with this one, it's a pulley system. It has 2 pulleys, and we're gonna show you the calculations that we did to show how it makes it easier. So when we measured it, if we pulled the rope starting from here, it would to the bottom of the wood. It's a distance of 30 inches, and for every 30 inches that we pulled the rope down, the weight would lift up 15 inches. So using the definition of effort, which is the work that we had to put in to pull this rope down to lift the weight, it's defined as force times distance. So the force, using the machine, the tool, we measured to be 4.88 pounds necessary to pull that rope down. So 4.88 times a distance of 30 inches. So I'm going to convert that into standard units. So 4.88 pounds converted into newtons would be 21.6 newtons times 30 inches converted into meters is 0.762 meters. So that the product of that would be about 16.5 newtons of force necessary to pull the weight up using this mechanical system. Now this shows that the system gives us an advantage, because if we were to pull the weight, the 8-pound weight directly up from the ground, just like with our arm or something, like up like this, you would need a direct force of 8 pounds. So 8 pounds converted into newtons would be 35 newtons. You would need 35 newtons of direct force to pull this weight directly up from the ground, whereas using the system, you would only need 16.5 newtons. Another way to show the ideal mechanical advantage of the system is a formula. It's basically the input distance over the output distance. So we know when we measured the input distance, which is the distance that we had to put in, was 30 inches, over the output distance, which was 15 inches, the distance that the object we were trying to move was lifted up. So in an ideal world, that's like where there's no friction, there's nothing that the energy that we put in can be lost to, the ideal mechanical advantage would be 2. There's a tension here and there's a tension here, even though we're just putting in one tension. So the ideal mechanical advantage follows our system. And then if you want to calculate the actual mechanical advantage, which is like including all the friction and like the real world energy that is lost, we would use output force versus input force. Since we were able to get a direct measurement of 4.88 pounds for the input force, we would just put that in. And we know the output force would be 8 pounds because that's the only weight that the weight could be lifted. So 8 divided by 4.88 would be 1.63. Now, the actual mechanical advantage is always going to be lower than the ideal mechanical advantage, just because, of course, there's that energy that we lose to friction. It's not gonna be exactly what the ideal mechanical advantage says. So to measure how efficient our machine is, we can use this formula, because like when you have a machine, you want to see how useful it actually is. So using the formula of work output over work input, we'll go back up to here. We're reminded that work is effort. It's the same thing. So we know work is force distance. So we're gonna do the force output times the distance output, which would make work output. So the force output was 8 pounds times the distance output, which was 15 inches, and the force input was 4.88 pounds times the distance input, which is 30 inches. And I'm not going to convert these numbers into standard units because ideal mechanical advantage, actual mechanical advantage, and efficiencies are basically just ratios to show you how useful your machine is. So 8 times 15 is 120 over 4.88 times 30 is 146.4, and that the number that you would get from that is 0.81. And efficiency is measured as a percentage, so we're just going to multiply that by 100 to get 81%. So what this tells us is that efficiency is defined as how useful a machine is, and when it's at 100% efficiency, that's the ideal. Like, you get exactly, your machine is working exactly how it would if it had the ideal mechanical advantage. But since we already went over about how friction makes it not ideal, the efficiency percentage of 81% makes sense.
If I make this, you give our project an A.